Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.96. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.96. Find the value of voltage Vx in given below figure such that 5 ampere current source supplies 50 watt of power. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this voltage source labeled as Vx. While one information is provided in this scenario, power supplied through this 5 ampere source is 50 watt. So without wasting time, let's proceed towards the solution. First of all, we will try to find out voltage across this 5 ampere constant current source because power of this source is provided in this scenario. And we know that power is the product of voltage and current. If we know any two quantities, we can calculate third quantity as well. In this case, we know the value of power and current, so we can calculate voltage. Equation for the voltage of this constant current source will be 50 watt divided by 5 ampere. It will become 10 volt. So 10 volt will be appearing across this 5 ampere source and the polarity of voltage will be positive terminal here and negative terminal here. Now because of series connection, this same current with same direction will also be flowing from 4 ohm resistance as well. So we can calculate voltage across this resistance using Ohm's law. That will be equal to the product of 5 ampere and 4 ohm. So voltage across this resistance will be 20 volt and the polarity notation will be positive sign here and negative sign here because current entering terminal is taken with positive sign. Modify the network by indicating voltage across these two elements with their polarities. Now we will apply Kirchoff's voltage law through this loop to calculate voltage across this 4 ohm resistance. For that purpose, we will assume the direction of current in clockwise direction and according to this assumed direction of current, polarity notation across this 4 ohm resistance is marked. Now write KVL equation for this closed loop. Start from here, current entering terminal is positive, so voltage across 4 ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so 20 volt will be taken with negative sign. Next, current entering terminal is positive, so 10 volt will be taken with positive sign. And at the end, current entering terminal is negative, so 5 volt will be taken with negative sign. Now add 20 volt and 5 volt together, it will become minus 25 volt. Subtract 10 volt from minus 25 volt, it will become minus 15 volt because the larger value have minus sign along with it. Place this minus 15 on the other hand side of equal to calculate voltage across 4 ohm resistance, that will be 15 volt. Modify the network by indicating voltage across this 4 ohm resistance. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 2 ohm resistance. For that purpose, we are assuming the direction of current in counterclockwise. Start writing KVL equation for this closed loop. Start from here, current entering terminal is negative, so 10 volt will be taken with negative sign. Next, 20 volt will be taken with positive sign because current is entering from positive terminal. and at the end current is entering from positive terminal, so voltage across this 2 ohm resistance will be taken with positive sign. Now subtract 10 volt from 20 volt, it will become 10 volt. And place this 10 volt on the other hand side of equal to calculate voltage across this 2 ohm resistance, that is minus 10 volt. Here minus sign is indicating that we have assumed wrong polarity notation across this 2 ohm resistance. Actual polarity of voltage across this 2 ohm resistance is opposite to the assumed polarity. So modify the network by indicating right polarity with voltage across this 2 ohm resistance. Now we know the value of current through this branch, that is 5 ampere, and it is entering towards this node. We will try to find out current through these two branches because voltage across the resistances are known. First of all, current through this branch will be voltage divided by resistance, 10 volt divided by 2 ohm, it will become 5 ampere. And the direction of current will be upward towards this node because current entering terminal is taken with positive sign. In order to make this terminal positive, current should enter from here and leave from here. Similarly, current through this 4 ohm resistance will be 15 volt divided by 4 ohm, it will become 3.75 ampere. And again the direction of current will be left to right towards this node because in order to make this terminal positive, current should enter from here and leave from here. Modify the network by indicating these 3 branch currents along with their directions. Now we can apply Kirchoff's current law on this node to calculate current through this branch. That will be equal to 5 ampere plus 5 ampere plus 3.75 ampere minus I is equal to 0. This I is the current through this branch and all of these currents are taken with positive sign because these 3 currents are entering towards this node. Only one current will leave from this node, that is I. Now add these currents together, their sum will be equal to 13.75 ampere and place this minus I on the other hand side of equal to calculate its value, that will become 13.75 ampere. So 13.75 ampere current is flowing through this branch in counterclockwise direction. Now we can calculate voltage across this 2 ohm resistance because current through it is known. So voltage across this resistance will be the product of 13.75 ampere multiplied by 2 ohm. It will become 27.5 volt. And polarity notation across this 2 ohm resistance will be positive terminal here and negative terminal here because the direction of current is counterclockwise through this branch. Modify the network by indicating voltage along with their polarity across this 2 ohm resistance. Now in order to calculate voltage Vx, we will apply Kirchoff's voltage law inside this closed loop because we know value of voltage across these two resistances. For that purpose, we are assuming the direction of current in counterclockwise. Write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so 15 volt will be taken with positive sign. Next, current entering terminal is negative, so Vx will be taken with negative sign. Next, current entering terminal is positive, so 27.5 volt will be taken with positive sign. Add these constants together, their sum will be equal to 42.5 volt. And place this minus Vx on the other hand side of equal to calculate its value. So the value of Vx inside this network will be equal to 42.5 volt. So this was exercise problem number 2.96. Thank you. See you again in next video.